Hello, can everyone hear me okay? Yeah, perfect. All right, wonderful. Thank you all so much for being here. It is a lovely 4:05 p.m. in California, or in Ireland, as we like to call it, 12 a.m. So I've had a great time climatizing to the fun of the conference, but I really haven't had a good time climatizing to the time difference, so forgive me if it's a little bit delirious. But my name is Lucas, and I'm here to talk a little bit about a new product, a new project that we're starting here at the company where I work, Eliatra, called Cortext IQ. But the overview of what I do is I'm a machine learning engineer. I work on this project, and before that, I worked for a finance company in automation, robotic process automation, and discovered that I really like to make machines do things that I don't want to do. So my company, or not my company, but the company that I work for, Eliatra, we provide this 24/7 enterprise-grade support for OpenSearch. We have our own distro. We do a lot of the documentation, training, workshops over in Europe. And now we're moving into these kind of like enterprise-level AI-grade solutions. And one of these solutions, the one that I'm very thrilled to be working on, is Cortext IQ. With this neat little tagline, if only you knew what your company knew or knows, which I believe our boss actually lifted from the CEO of Siemens or Simons, was something that he said off the cuff in a talk once, and he said, that's really cool, we'll take that for this product. But the core idea of Cortext IQ is it's looking to get around one of the biggest barriers that a lot of companies in Europe have as a result of GDPR and data privacy laws, which is you can't sell the data or give the data to third-party institutions or companies outside of Europe. So this is obviously a big issue for people that want to use the big players in large language models and Gen AI, things like Claude, OpenAI's ChatGPT, all that sort of things, which sucks for them because it's, you know, that meme of Squidward looking in the window at Patrick and SpongeBob running outside having fun. Everyone else gets to use these cool tools, whereas they have to abide by these really strict data governance laws. So Cortext IQ is tackling this problem by trying to create this on-premise, or in some cases managed service, solution that brings data processing pipelines, vector database capabilities, and ultimately this front-end large language model Gen AI solution completely within their own data architecture. So they'll be able to utilize this product with their own data, embed their data, upload it, and then almost have an internal enterprise-level search engine with their own little large language models that they can either use from the open source community or perhaps even fine-tune themselves. So what is the overview of this product, and what are kind of the core pillars that make it what it is? The one that does the heaviest lifting, by far, the most major component, would be the Apache NiFi data pipeline. If you don't know what Apache NiFi is, it's essentially this incredible piece of software that allows you to create these highly modular data processing workflows. And at the very start of it, you send in all types of data, structured or unstructured, and that can come from CSVs, XLs, images, videos, but I'll get into that in a second. Next is, of course, OpenSearch, which we all know and love, using it for its vector embedding, storage, and retrieval capabilities, allowing us to do things like hybrid search, KNN, approximate KNN, and all that good stuff that makes large language models able to learn on the go. And then finally, we have the middleman, the Helix AI platform, which allows users to be able to load large language models directly onto their own machinery using their own hardware. There's no business with, you know, API keys, cost per token, inference. They're using their own hardware, their own machinery to generate these responses and use these data analysis skills that large language models are well known to do, or be able to do. So let's go through each of these step by step. At the very end of this, I'm going to be doing a cool little demo. I know it's a cardinal sin of presentations to do a live demo and these sort of things, but, you know, hopefully it works. If it doesn't, I'll promise to clap and cheers if it's going really, really well. But first of all, we have Apache NiFi. So this is where we're building essentially our data processing blocks. We're taking all of our data, as I said before, things like JSON, PDF, CSV, and we can take images, videos, audio, transform that data into a structure then that we can vector embed, and then finally upload it to OpenSearch and use that later for RAG, retrieval, that sort of things. And it's absolutely brilliant. Every step of the way, you can do some sort of logging, auditing, you know what's happening with your data, you have a high level control of where it's going, where it's been. You can even add things like the ability to obfuscate or secure different types of data depending on the source. It's incredibly modular, and it runs through Java or even in Python with the Apache NiFi 2.0 release. So that's absolutely wonderful. As I said, it does most of the heavy lifting for this platform, as we're able to offer these almost bespoke solutions for each company, because everyone's going to have their data in a different format, in a different file type, and maybe they want that data at the end step to look a little bit different. And the modularity of Apache allows us to be able to do that on the fly almost. Next, continuing with NiFi, but I have already said this, is we have, once again, our custom components that we're building for each of these clients, but also we have a high level of reusability with each one. And then we're also able to embed different types of models into this pipeline to do things like inference, to vector embed different types of text, even process images into image descriptions or extract metadata that we can then vector embed and upload to our databases. So all of that, all happening locally, all happening securely, no need to send any data out to third-party solutions, and you have a high level of control over where your data is going and what it's doing. Next, we have OpenSearch. What more is there to say about this? It's a critical aspect of that platform. It allows us to securely upload our data and quickly and securely retrieve it. We can do a number of things with that kind of retrieval process, where we can just do KNN, proximate KNN, hybrid search. We can choose what types of data we can retrieve at search time. We can use the security plugin to secure our documents at both fields, document, or kind of an overall security level. So that, for instance, if the CEO of the company is wanting to hook his email inbox to Apache NiFi, that means that Jeanniot from finance won't be able to pull this down for a RAG solution later on in the process. Now, finally, we have the front end of the platform, but this service, once again, that allows us to load different types of LLMs onto our hardware. It's called Helix AI, and we're using this as a middleman software. There is very much a front end that comes kind of with the platform. What you're going to see in the demo was just hacked together by me. I'm not a front-end dev, so please don't make fun of me for it. But this is what ultimately will allow us to use these open source or these local LLMs without having to call to a third party to either incur costs via the token to inference cost, or having to use an API, or having to send our data outside of this platform itself. But yeah, those are the three kind of core components that make up the Cortex.IQ platform. The final one as well, which is really cool, is the tools or agent system of Helix AI, which when we are doing inference on the front end, we can use the large language models as you would in everyday use. Hello, how are you? What's 2 + 2? It's 4, blah, blah, blah. What we can do with tools in Helix AI is we can actually have it looking for certain triggers or keywords in that user's query. I call it something kind of like RAG AR or RAG request, where it won't go and look for data according to in a certain database until it has triggered that the user is actually asking for that. So rather than always front-loading data that you might not necessarily need in a response, it's looking for a request to go and find that kind of data. And you can have loads of tools active at once, and it'll just trigger based on those certain things. So the example you'll see in the demo is if you're a HR manager and you're looking to filter through all of the job applications in your inbox, and you're looking for specific individuals in that, you could be using it as a normal day-to-day thing, and then you could ask it, I'd actually like you to retrieve a candidate for the role of a software engineer. And now it goes, OK, don't have that in my existing corpus of knowledge, but I do know where I can find it. It'll query our OpenSearch database, it'll retrieve the necessary information relating to applicants for a software engineering role, and then it'll be able to give us the answer based on that. So yeah, that's it from the presentation side of things. We're going to move into the demo because I do think it is way cooler. But thanks for listening, and hopefully that made sense. If that didn't, hopefully the demo will elucidate a little bit more. Oh, 1 second. Off to a good start. We're knocking on the door in a server in Germany for this one. Everyone promised to look away. Alrighty, so what you are looking at now is the front end, excuse me, the server, the GUI that I'm using for this is very, very slow, so it's going to jump around a little bit. What you're seeing at the screen right now is the Apache NiFi pipeline. And all of those squares you're seeing, the big ones, are all called processors. And under each of those processors is code, specifically Python code, some of them Java, but the ones that we built and we're custom building are all in Python. And each of those are acting on data in a specific way. We wanted to transform the data in some way. And I'm not sure if you can make it out, but I'll zoom in a little. We'll start at the very top of this pipeline here, where we're just, what have I done? Excuse me. Hiding that one away. I'll go up. So, starting at the top of this pipeline, we have our kind of ingest service. And for this demo, it's literally just a folder on my computer. But it could be from a wide range of different sources. You could have an email inbox, as I said before. You could have a file server, folders, other databases. And you pull this data and you pass it through this pipeline and you transform that data as you see fit. For this demo, we're taking two types of data and we're transforming them in different ways. We are taking just simple JSON files, and then we're taking images, PNGs, JPEG with an E, and we're going to be changing that in some way, and we're going to be structuring it into a JSON representation of that data, and then we're going to be uploading it up to OpenSearch later to use for RAG. So before I begin, I'll kind of explain the data that's going through it. So for the JSON side, we're going to be sending two JSON documents, each with 25 objects containing job descriptions, job applications, the name of the applicants, and their CV. So as I said in my HR example before, that's where we're going to be drawing that data from. On the images side, it's a bunch of stuff that I found online, some of it that has geotag, some of it that is pictures of dogs, pictures of the London Bridge, pictures of people sitting in a room, and we're going to be extracting a couple of things from those images. We're going to be extracting the name of the file, the location of the file in the file server, the EXIF data or the metadata, such as geotag locations, where the photo was taken, what device it was taken on, and then we're going to be adding that to the attribution of that file, and we're going to be passing it through a large language model called Lava, which is an image parsing image description model, and I'll just see if I can get it over here. Yes, the describe image processor here. And we're just going to be asking it a simple question. We're going to decode that image. We're going to send it into the model. We're just going to describe this image. Tell me what's going on in it. It's going to generate this description of the image, append it to the metadata that we have already extracted. And then finally, it's going to vector embed all of that information, append that again to the flow file, and upload that all up to OpenSearch. On the JSON side, we are chunking this document into its 25 individual objects, so the 25 applicants. We are then very simply vector embedding those applications, those objects, and then we are uploading them to OpenSearch in an index of its own. The index setup is very simple. I'll show you here. Hopefully it doesn't scream at me. So yeah, we look at the image one, for instance. We have, all the normal things you'd see in these vector-capable indexes. We're enabling KNN. We are setting our indexing property. We are making sure the dimensionality is correct because our embedding model is giving us 1024 vectors, and we need to play nice with that. Setting the method, the engine, Lucene, all of the information that we are extracting in our pipeline, such as the image description, the attributes, such as the file name, the file location, all of this metadata. Oh, it's really not scrolling very well here. 1 second. Yep, there we go. The EXIF data, such as the date time when the image was taken, the geopoints, which are the latitude and longitude, and we're actually converting those latitude and longitude into actual places on the map at a point in that pipeline. And out of that, I was able to build a cool little visualization in dashboards where, as I passed all these photos in, it actually populated a world map showing me where all these photos have been taken. So right now, these indexes are empty. And the reason for that is I'll show you this front end. Promise not to laugh. And this is kind of what it looks like from this thing. So this is our inference front end. And right now, this is hooked up, and it should work just to an LLM. So we can just do, hello. And we'll get a response. It's just loading it into the memory. And you again. OK. Obviously, we've talked before. But yes, so right now, we're using Llama 3 for this one. And it's really happy to see me, as you can see. And right now, it's almost completely useless from a business enterprise point of view, because we're not feeding it any data. So for instance, if you will, a scenario where I am a HR manager, can you retrieve an applicant for the role of software, I typed very loud, I'm just realizing, engineer. And it's going to give me that standard LLM response where they're all trained to be super helpful and always want to give you an answer. And they're like, sure, yes, I can help you find an applicant for the role of software engineer. But I have nothing to go on. I have no names. I have no idea what type of role you're applying for. How can I help any further with that? Well, we're going to do just that. We're going to go to this neat little folder here, source, where I have my JSON description, my job description JSON documents, and all of these images. We got a cute little puppy. We have that meme of the old guy with his coffee mug. We have the London Bridge Tower and loads of other images. All at once, we're just gonna boop, drag them in, upload them, go back to NiFi, and kick it off. And immediately, it's going to take all of the files from that file server. It's going to route them based on the attributes. So the JSON will go this way, the images will go that way, and it's going to do all of the things that we ask it pretty please to do in that data pipeline. And in the time that I've been speaking, it's already all done. It's all good to go. We can go back to our front end. And we can, because I don't want to type it again, so there. Oh. We're going to copy it. We are going to send it back in. And we are going to pray. No, it's going to work. It's going to work. Bada bing. So now it knows it has triggered this tool going, OK, you're looking for something specific. You're looking for something relating to a hiring process, because that is the tool that we've set up for this pipeline. That it looks for when the user is requesting something regarding a job application or a hiring practice. In the Helix platform, we have a thing called the tool that I described before, which is just an OpenAI schema that is going to go retrieve that information, front-load it into our response, or into our query, and then give us the information we want back. And it doesn't just stop there. We can continue to ask questions. Now that data is loaded into the memory, because it has conversational memory, we can ask follow-up questions. We could ask things like, OK, cool, we liked, what's his name, James. But what are the other applicants? How do they shore up against James? And we can do that for a whole different range of jobs. So that is the RAG side of things, the enterprise data. But this is the part that I like. I kind of like this one. As you'll notice as well, as you remember, we also did images. We got our image descriptions. We've uploaded them to our database. So what can we do with that? So I'd like you now to consider a scenario where I have just returned from my holidays in London. And I really want to find the photos that I had taken, particularly of maybe the London Bridge. Please work. And just like that, this one we're not really using LLMs for. We're using that description that was generated by the LLM to be able then to quickly and nicely, I hope, behind the scenes, retrieve those images that we have on our system. But we have the location of that file. We have the description of that file. We have the geo points that we extracted from that file and then converted into an actual location. And we're able to get it back. So if I want to do something like photo of a dog. Imagine it didn't give me one. There we go. Or I like this one. Unfortunately, he's not here, but photo of two guys sitting. He's going to appreciate me doing this, but that's my boss and my other boss. This is a photo that we use as a test case for this. But yeah, That is essentially the early. So this is kind of something that was in R&D for a while, and now we're slowly starting to move it out into that very exciting production phase, and we'll be opening it up to things like PDFs, which I know are a hot topic in data parsing at the moment. The talk from Adobe was real cool. And image, video, audio, all that sort of stuff. If you want to have a look at what a pipeline with more data types looks like, this is kind of that sprawling web where we're trying to deal with as many different file types and write as many different file types and get it all working. And it's very exciting. But yeah, thanks everyone.